All right, in this video, we're going to talk about the difference between Bohr models and Lewis structures. And what I like to talk to my students about and tell them one of the easier ways to remember which one is the bigger one with more stuff in it, or which one is the smaller one with minimal stuff in it, is that Bohr needs more. Okay, Bohr needs more. So keep that in mind. Bohr needs more. Now, in both cases, we're going to look at, for example, the bottom of the reference table is the electron configuration. The electron configuration is going to tell you the order in which those electrons are arranged in that atom or the atomic structure. So chlorine, for example, atomic number 17, has 2 electrons in its first energy level, 8 electrons in its next energy level, and 7 in its last energy level. The other thing we want to focus on, this 7, which is an important number, is also called the valence level, or your valence electrons. Now, those are going to be important for one of the two structures. Obviously, they're going to be involved in both of them, but with Bohr, obviously, we need more. So the Bohr model often will have the symbol, and then will represent all 3 rings. Within each ring, you're then going to represent the correct number of electrons that you see that are shown in this scenario. So in reality, on your reference table, it's called the electron configuration. It's really the Bohr configuration. So I would have, for example, 2 electrons in my first energy level. I'd have a combination of 8 electrons in my next energy level, and then finally 7 in my last. So Bohr needs more. Now, sometimes you may see some numbers in the middle of your Bohr model that represent the number of protons and neutrons, depending on the isotope that you have. The Lewis structure is going to be a lot simpler, and it only reflects the valence electrons. So chlorine with 1, 2, 3, 4, 5, 6, 7, and then it's done. Now, the Lewis structure is going to save space. It's going to save time. It's a lot easier when you're drawing a lot of structures, a lot of diagrams. It's a lot easier to compress into a textbook. It's less, for example, less ink that the company's going to have to use. And it also is going to give a good representation of the structure and the overall alignment of how those molecules are combined and bonding together. Where this is going to get big and bulky and going to take up a lot of space. Obviously, you could draw them, but it would take a lot more work and a lot more effort compared to drawing with the Lewis structures. So Bohr models are usually only shown, or we only represent them when we're talking about individual atoms and individual elements. Lewis structures, when we're talking about bonding, and we have multiple atoms together, we're going to use the Lewis structure. Bohr models are also great when you talk about excited state electrons and ground state. So for example, these numbers, all 3 of these numbers right there are called the ground state. And what happens when an atom gets energized, they will actually gain energy, and one of these electrons, for example, let's call it this one, may jump to that outer energy level or a higher energy level, and that becomes excited. So instead of 287, it now becomes 188, because one of the electrons on the inner shell jumped to the outer shell, and it becomes unstable. And what happens is that unstableness results in light when the energy is released as that electron falls back to the lower energy level. So eventually this one that came out here may stay there, but maybe another one falls back to replace it. It doesn't necessarily have to be the same one that jumps out and jumps back. It could be one jumps out and another one falls back. So there's lots of different combinations. So a totally different video, we're not going to talk about it much now, but when you get into flame tests or bright line spectra, it's all because of this excited state electron gaining energy and jumping out. When the electron releases the energy and goes back, that's when the light is created. So hopefully this makes sense and you understand a little bit more about the difference between a Bohr model and the Lewis structure. Again, the thing to remember is that Bohr needs more, all right? So you're going to use every single number that you see in that configuration. All right, thanks.